Hello, this is Mrs. Edwards, and we are going to work on problems 7-119 to 7-125, review and preview from the CCG book. Problem 7-119 says, the diagram below shows three bold statements. Find the coordinates of the midpoints of each segment. So just looking at line A, if I want the midpoint of the segment, I notice that it is here. I can do that by visually looking. If I jump 2 from the left, 2 from the right, I know it has to be halfway in between that middle section. So then I want to write the ordered pair, 1, 2, 3, 4.5, comma 3. Looking at segment B, I can also tell that my midpoint is here, so I'm going to go -3 on my x-axis, up 1.5. Looking at segment C, I can tell that my midpoint is right here, and that is +1.5 on my x-axis, -2 on my y. Problem 7-120 says, examine the diagram below. Question A says, are the triangles in the diagram similar? Justify your answer using similarity transformations. So looking at our triangle, we know that line segment SR is congruent to line segment RK. We also know that angle SHR is congruent to angle SAK because they are both right angles. We then can state that SR is half of SK, so SR times 2 would give us the length of segment SK. So we can say that we then also know that angle HSR is congruent to angle ASK because it is a shared angle. So by the definition of angle side similarity, we can say that triangle SRH is similar to triangle SKA. It is dilated by a factor of 2. Question B says, what is the relationship between HR and AK? So when we look at HR and AK, we can see that if we multiply HR by 2, it should equal AK. Between SH and SA, SH and SA, we can say that if we multiply SH by 2, it should equal line segment SA. And when we look at the relationship between SH and HA, we should be able to say that SH is equal to segment HA. If SK equals 20 units, and RH equals 8 units, what is HA? So we can determine that by looking at our smaller triangle, and half of 20 units is 10 units. So when we use the Pythagorean theorem, 10 squared is equal to 8 squared plus SH squared, which is equivalent to HA. So if we take 100 and we subtract 64 from that because it's the inverse operation, we get 36 equals SH squared. The inverse of squaring something is square rooting it. So we get SH would equal 6 units. And we know from up here that SH is equal to HA. So segment HA would be 6 units. Question 7, 121 says, examine the spinner below. Assume that the probability of spinning a -8 is equal to that of spinning a 0. Find the spinner's expected value if the value of region A is 8. In order to find the expected value, we take the probability of each section times the number in the section and add them all together. So if A is equal to 8, we are going to take the probability of spinning a 6 times the number 6. We're going to add that to the probability of spinning a -8 times that by -8. We're going to add that to the probability of spinning a 0 times that by 0. And we're going to add that to the probability of whatever A is multiplied by the value of A. So when we look at probability, there is a 50% chance, so 1/2 chance of spinning a 6. If we divided this circle into 8 even sections, the probability of spinning a -8 would be 1/8. The probability of spinning a 0 would be 1/8, and the probability of spinning section A would be 1/4. So in example A, the probability of spinning a 6 we said was 1/2. So if we take 1/2 and multiply that by 6, we're going to add that to the probability of a -8 would be 1/8 times -8 plus P of O is also 1/8 times 0. And then the probability of section A is 1/4. And in this case, they wanted our A to represent 8. So to find the expected value, half of 6 is 3. 1/8 of -8 is -1. 1/8 times 0 is 0. And 1/4 of 8 is 2. So when we take 3 plus -1 plus 2, we get an expected value of 4. So the next problem says find the spinner's expected value if A is equal to -4. So we're going to change this piece to evaluate the expected value for -4. So we're going to take 1/4 times -4 this time, which 1/4 of -4 is -1. So our 3 plus -1 plus 0 will stay the same, but then we have 1/4 times -4, which is -1. So we get 3 plus -1 plus 0 plus -1 gives us an expected value of 1. What does the value of region A need to be so that the expected value of the spinner is 0? So if we set this up, we have 3 plus -1 plus 0 plus 1/4, because that's the probability of section A, times what region A needs to be, and we're going to set that equal to 0. So 3 plus -1 is 2, plus 1/4 A equals 0. Inverse operations, we subtract our 2. 1/4 times A equals -2. The inverse of division is multiplication, so A is equal to -8. 7-122, for each pair of triangles below, determine if the triangles are congruent. If the triangles are congruent, state the triangle congruence condition that justifies your conclusion. If you cannot conclude that the triangles are congruent, explain why. Example A, we are trying to prove triangle CAB is congruent to triangle CED. So we can tell that they have an angle already in common, they have a side already in common, and then I noticed that angle ECD and angle ACB are congruent because they're vertical angles. So by the definition of angle-side angle congruency, we can say that these two triangles are congruent. When we look at example B, triangle CBD looks to be congruent to triangle EFG. So side CB is congruent to side EF. Angle CBD is congruent to angle EFG, and side FG is congruent to side BD, so we can say that these two triangles are congruent because of the side angle side congruency theorem. Looking at letter C, triangle LJI appears to be congruent to triangle HJK. And let's see if we can prove it. So they said that this piece, LK, is congruent to HI. So if we have, and they also said IJ is congruent to KJ. So if we have HI and add that to IJ, we can say that it's equal to LK plus KJ. So that would give us, if you look at your two triangles separately, that would tell us that this side is congruent to this side. So HKJ, LIJ. We notice that these smaller pieces, KJ, is already congruent to IJ based on our picture, and then angle J is a shared angle, so we can say that these two triangles are congruent based on the side angle side congruency theorem. Looking at question D, triangle PRQ looks to be congruent to triangle SRT, but looking at these two, we have three angles that are congruent, but that does not tell us angles in a triangle congruent is not enough proof to say that two triangles actually are congruent. So D would be, we do not have enough information to determine congruency. Question 7-123 asks us to revisit the problems from 122, the triangles we just looked at, and create a flowchart or a 2-column proof for our conclusion. So looking at letter A, we concluded that triangle CAB was congruent to triangle CED, but if we use statements and reasons and make sure we list our statements in a logical order, we know that angle DEC was congruent to angle BAC because that was given to us. So right here. We also know that line segment EC is congruent to line segment AC because that was also given to us. Then looking at our triangles, we know that angle ACB is congruent to angle ECD because they are vertical angles. And then we can conclude that triangle CAB is congruent to triangle CED based on the angle-side-angle congruency theorem. Looking at B, we stated that triangle CBD was congruent to triangle EFG, and then if we fill in our statements and our reasons, we were given EF is congruent to CB. We also were given that angle CBD is congruent to angle EFG. They were both given, and then more specifically, they were given that they are right angles. And then we were also given that line segment FG is congruent to line segment BD. So based on all the given information, we can conclude that triangle CBD is congruent to triangle EFG based on side angle side congruency. 7-124, Carolina compared her proof to Penn's work in problem 7-113. Like him, she wanted to prove that if line segment AD is parallel to line segment EH, and BF is parallel to CG, unfortunately, her statements are in a different order. Examine her proof to help her decide if her statements are in a logical order to prove that angle A is equal to angle D. So reading through the proof, the first step she has is that our parallel lines, which were given, so that is in the correct place. Also looking at our proof, we have A is equal to D, which is at the very end because that's the last thing that we are trying to prove. Now we need to talk about the insides. So she said that angle A is congruent to angle B. If lines are parallel, alternate interior angles are equal, which is true. So that is in an okay place. She said that A is equal to angle angle C based upon substitution. And then step 4, she said B is equal to C. So angle B is equal to C. If lines are parallel, corresponding angles are equal. So actually, statement 3 depends on statement 4. So switching the location of these two statements would make it flow more logically. And then C is equal to D based on vertical angles are equal is a true statement, and that could remain where it is. It could also go up under number 2. if it needed to, but logically just switching 3 and 4 makes our proof flow better. 7.125, describe the minimum information you would need to know about the shapes below in order to identify it correctly. For example, to know that a shape is a square, you must know that it has 4 sides of equal length and at least one right angle. Be as thorough as possible. So the minimum amount of information we would need to know to make sure that it must be a rhombus is we would need to know that it is a quadrilateral, and we would also need to know that the 4 side lengths are equal. And that would mean it must be a rhombus. In order for it to must be a trapezoid, we would also need to know that it is a quadrilateral and that we need one pair of opposite sides parallel.